Hello and welcome to this webinar. I'm Per Rohdin. I work at product marketing here at Tacton, and with me as a co-host I have Alex Weiss over in Chicago, and Alex is our senior sales engineer. And we'll be talking about configure to order, how to offer individualized manufacturing products with controlled costs. So before I hand it over to Alex, let me give him a background of what is configure to order and what is product variance, because that's really what we're trying to achieve here. So we serve these kind of customers, B2B manufacturing. These products are typically quite complex, heavily individualized, high value, and with a complex supply chain behind it. And oftentimes the product variance, the individualization of these products, it's quite high in order to address the customer needs. So if we think about the digital transformation and the challenges that these companies actually face today, there are lots of things to consider, but we will focus on one of those challenges today, and that's the individualization, how to mass customize your products, how to increase that product variance, and why it's important for you to do that, and how can you do that with a controlled cost, basically. So, a bit of a history. If you think about in the start of the Industrial Revolution in the 1850s, basically every product was unique. It was handmade and handcrafted. So the product variety was endless. It was huge, right? But so most of the products that were produced were done in one unique copy, so to speak. Then as the manual the more industrialized production took speed, we went into this mass production phase where maybe Ford is one of the biggest or most prominent examples, where the mass production capabilities standardize the products in such a way that you basically reduce the product variance. So Henry Ford's quotation here is typical of this era, where people can have the Model T in any color as long as it's black. So that was the low tide of product variance, but the product volume, each of those variants was quite high, making it cheap. Then we've seen since the 50s, we've seen a path back towards product variety and product variance. We customize the mass production different ways. The robotization, of course, has made a great impact here. And as we now move into the 21st century, we've seen a number of technologies that allows us to increase that product variety again, still keeping the cost down. And 3D printing perhaps is the most prominent example here, that can actually make unique products with the same cost, driving product variance and individualization for the end customers. So we are back to square one now, so to speak, compared to the Industrial Revolution. And why is this development taking place? Well, you can do standard commoditized low mix products, of course, but competing in such a market actually forces you to go into this cost. You battle your deals with cost and price rather than value. So when you specify and differentiate yourself, make your products more unique, that's when you can compete on product fit, the value, and on the outcome of your products rather than the production cost and investment price. So you also come closer to the customer's business. So that's really the lengthening the tail, or the digital disruption that we want to achieve. That's where these companies want to position themselves in. So making the volume of each product variant smaller, and making the variance of those products higher, or maximize that. And that's what CPQ and configure to order is really all about. But so these companies try to address these challenges with engineer to order. So one way of fulfilling that product variance is, of course, to enable or empower your engineers to make this custom design, but by hand in manual fashion. But that is not scalable. There are a number of problems with ETO-based sort of customization. You have too unsustainable sales cost and the customer acquisition cost. Those manual ETO-based solutions create errors in ordering and production. You degrade your margin that you thought you had in the beginning of the project because there are so many errors in your quoting and then your ordering that the margin that you thought you had at the time of quoting evaporates as the project evolves. Also, the product knowledge that requires is internalized in your sales engineers' heads, and thus is difficult to store and to share across your company. And of course, ETO engineers, they are under pressure. They create off-target cost estimates and design errors and risking oversizing solutions because they're not quite sure about the product fit. So there are a number of problems with having an ETO-based approach here. So what we really want to do, the challenge here, is how can we create that product variance, that differentiation, that value-driven outcome-based products individualized for that particular customer with controlled cost. So how to move basically the engineer-to-order flow over to a configure-to-order flow, maintaining the same product variance that we have, but with lower cost, industrialized cost, lower risk, decreased lead times, and better quality control. So that's really what we're going to talk about here today. So with this, I hand it over to Alex, who will be giving a demo of how this can be accomplished within Tacton CPQ. Over to you, Alex.
Thank you, Per. My name is Alex Weiss, and I'm a senior sales engineer at Tacton. And my goal is to walk through the mechanisms that can support your complex configurations within Tacton. So first, before we do that, I'm going to walk through a quick video demo. That way we can level set on configuration and better understand those mechanisms. So in this example, perhaps I'm a sales user and I'm wanting to configure and quote a truck. I have the ability to make these different selections, such as inputting application requirements, which these can be critical to the application. And then I can select the options that have been requested from my customer. In this case, I'm configuring what could be considered different sub-assemblies of the truck. This could be things such as the wheel configuration for the chassis. And then also notice in the background, I'm having calculations that are firing. I'm executing everything from simple to complex calculations, such as aggregating the total tank volume. And this can be important data that might be important to share back with my customer. Another thing to mention here is I'm also creating a sales bill of material and executing pricing. All really important data, not only so that I can quote my customer, but when it becomes an order, I have an accurate bill of materials. And then, of course, another important part around this configuration is the logic. You'll notice here that there is logic being enforced using Tacton's constraint-based solver, and I'm also able to resolve those conflicting choices with this conflict resolution. So you're able to do this without the need of engaging additional engineering resources, but of course, if we do want to incorporate that option, we do have the ability as well to incorporate an engineer-to-order type of workflows. All things we're going to dive deeper in this presentation. So now that you saw Tacton CPQ though, what are those mechanisms that we have to support your complex configurations? So let's dive into some more detail here. Like Per stated, product variance, configure to order, these can be essential differentiators for your business. And at Tacton, we aim to empower our customers to have a simple approach to make these complex configurations. So we think it all starts here at the product structure. So take this truck, for example. There's many different components and many different assemblies. These different assemblies are broken out on the screen here. We have a cab, a powertrain, fuel tanks, body, chassis, all of these different sub-assemblies part of the total assembly. Now let's break this down even deeper here. So each one of these different assemblies has different modules that are part of that assembly. So in this example here, we have a tire and wheel combination. We have these front rims. That front rim can be considered a module, and those modules can have different features. So that front rim, for example, could have different materials based off of the selection. This could be aluminum, it could be steel. Those different features then have different domains. And so that domain for the aluminum or steel, for example, would be that material domain. So there we have the module, the feature, the domain, and then to look at this in the example of this table here for the product structure, notice that we have different features for the module: item number, diameter, material. Then we have the module variance. These are the selections that the user can make. And then we have the feature values. So the different rim diameters, for example, the 24-inch rim diameter. There we have it broken down a little bit deeper with our module, our features, our domains, and then also those different variants. So now here's the total product structure to capture what we call the product model. And this has the set of different assemblies with the different positions that are actually realized by those different modules. So to parallel this terminology with that truck example that we walked through, we have the product model, which is the truck, and then it's complete with the assemblies like the powertrain, the fuel system, the chassis. And if we look at that chassis, the chassis is realized again by those modules. We have the cab, the tires, and then with the tire, we have those different rim variants and features, for example, the 24-inch rim diameter. Another important thing to mention here is that when it comes to the structure of your product, maintenance is really, really important. And being able to reuse data can really reduce that maintenance time. So in Tacton, you actually have the ability to reuse these assemblies. So what does that mean? Well, in this example, perhaps you have a chassis that you can use across different products, such as you have a chassis that gets used for a freight truck and a chassis that gets used for a bus. So you can maintain that single assembly, but you can seed it in all your different products. So there we have it for the product structure. Now let's talk about the data. So we like to think of this in two different ways. We have the product structure, then there's also the data, and then creating the logic. So you may have data stored in different places. Perhaps it's in your back office system. A lot of our customers have it in Excel, or perhaps it's all in someone's head, which is what we call tribal knowledge. Now at Tacton, we support different ways to import that data. One of those ways could be Excel. Of course, you could just import that data directly into the product structure. Another common way is integrations. It just depends on where your source of truth is. So let's say that you have all the modules and the variants in Excel, you simply import that data. Or if that data lives in a PIM system, a PLM system, an ERP system, it's very common in the ERP you have data like SKU numbers, item masters, weight, pricing information, and different properties. Tacton can integrate to your systems so that the configuration is always referencing the most accurate, up-to-date information wherever you choose to maintain it. So integration, again, very typical. Most of our customers leverage this using our REST API. Again, it is very important to distinguish between data and logic. The data is important. The data is imported while the logic can still execute on that new data. So let's dive into logic here next. So Tacton was designed with the intention to manage rule complexity. Simply put, you define not what can be combined, but how these things can be combined. If a tire has an internal width of 24 inches and a wheel has an outer width of 18 inches, it would just make sense that they're not compatible. So Tacton Solver Engine does this with creating the relationships between the modules and the features, and it really allows it to be infinitely scalable and much simpler to maintain, where perhaps you have thousands of rules before, you can take that down into much less constraints. So the types of logic within Tacton CPQ, we have again the constraints. And a majority of your logic will be built with constraints. This is referencing feature on different variants that you can draw those correlations, such as we've talked about the wheel and rim example, but in this case, in this image here, we have a transmission. So a transmission on an engine, we want to ensure that the transmission selection doesn't exceed the max torque on the engine and vice versa. Another simple and sleek way to create logic would be combination tables. And combination tables simply allows X to be compatible with Y. You don't have to draw features or correlations between the two different modules. In this example, you can see that we have a wheel configuration, a 4x2, works with one axle and on a dirt road only. So just basically simply put, with the different selections that the user makes, there's going to be options based on the combination table. So very simple way to create logic as well. Now part of your logic may also include equations. So with Tacton CPQ, you can aggregate data and execute calculations. So what does that mean? Well, For aggregating your data, perhaps you want to sum the total weight of your truck. This could be really important to take all the feature weights, all the module weights, and that way you can build a constraint around it. So based on the weight, like perhaps in this example, when you have a weight over 5 tons, you want to use this chassis versus this chassis. Or maybe you want to compute a calculation based on the size of the truck, which would be based on the size of the truck, we want to understand the turn radius. That could be a calculation that gets placed on a data sheet. So all of that said though, if it's not enough, we also do integrate with external systems like simulation systems that you can send out your data to and send it back in a Tacton CPQ. So we support a lot of rule complexity, but there is purpose-built software that may be best fitted for your needs, and we believe that you want to use best-in-breed CPQ as well as best-in-breed simulation software. Okay, so you have constraints. Now what about optimization? So the optimization can be enforced with the constraints. So in this example here of this tire and wheel combination, you can see there are many, many choices that you can make. Across the board, perhaps hundreds, thousands, maybe millions of selections that you can make in your products. Now we could first start with creating technical constraints. For example, with this wheel and tire combination, the inner diameter of the tire equals the outer diameter of the wheel, and then you want to have all of the widths equal. And now we can introduce things like market constraints. In this example, perhaps we have a vehicle type. 4x4 is going to be an all-terrain style of vehicle. Maybe a sports car only has the rim material available of aluminum. As we continue to constrain our products, perhaps we include local constraints like location. Sweden versus Spain. Sweden has a certain tire width versus Spain is not going to need tires for winter. And then incorporated things like guided selling. So initial questions, what are the road conditions? How often is this vehicle going to be used? All very important for configuring and guiding your user to making a selection. And then the last thing is there's many of ways you can constrain your product, but there is only one best option, and that's the optimization. So perhaps you want to pick a selection that is the lowest weight. There's going to be one best option for that, or best performance, shortest delivery time, lowest price. We're able to optimize and make sure that you can actually quote your user and configure the product that meets that optimization criteria. Okay, so now what happens when you make your selections and you actually violate a constraint? Well, in Tacton CPQ, we have what we call conflict resolution. Now, the configuration starts valid, but you'll notice as the user makes selections, that padlock becomes locked, and that actually shows that the value is committed. So to speed up configuration, Tacton Solver Engine will implicitly make these different selections while the user makes selections that are explicit. And if there are two explicit selections that are in conflict, there's going to be a window that pops up to allow you to resolve that. It's going to trigger that automatically. So now you can resolve that conflict. It could be one to many conflicts with the click of a button. To take configuration a step further, as you configure your product, Tacton CPQ can build out a sales bill of material. So at Tacton, we find this is a critical piece of actually reducing engineering time and creating that configure to order product. So Tacton will actually support your sales BOM down to the lowest level of configuration, which could be a single level bill of material, a multi-level bill of material. But by establishing that BOM definition, those different attributes on the BOM can be established, or it can be pulled from your ERP or wherever your source of truth is, so that your BOM items can be leveraged to show and create more data, such as the weight, the labor hours perhaps. Of course, pricing is pretty uncommon. Whatever is important to be viewed in the bill of materials, you can display that to your user. Additionally, we have this concept of fixed versus dynamic positions, meaning you could set the value for the quantity or have it based on logic to determine the item on the BOM as well. So for example, for a fixed bill of material item could be a steering wheel, or maybe a dynamic BOM item could be the axles, which could be defined if you have maybe a double axle versus a tri-axle truck. Notice the pricing information. The focus of this presentation is not on pricing, but of course Tacton does price execution, and it can be customer facing as well. Once the configuration is completed and quoted, then the project can be brought to order fulfillment. So upon order, these integration endpoints can be established via our REST API. For example, when the truck is ordered, the sales BOM can then be passed back to the ERP and explode into a manufacturing bill of materials. And that's when where you can begin production of this configured truck. So at this point, I do want to mention that at Tacton CPQ, we are integration agnostic. Our goal is where you can leverage a REST API and integrate to any of your back office systems. So we only focus on CPQ and manufacturing CPQ at that. All right, so we've established the product structure, the data and the logic, the BOM creation, integration. Now let's segue into Tacton administration. And this is a very, very, very key part of any CPQ implementation. Now in Tacton CPQ, in Tacton CPQ administration, you have the ability to collaborate on the creation of your front-end environment. So what does that mean? Everything is controlled with permissions in Tacton CPQ. Now as administrators, you can break up the work, meaning you can work on different sections of your product by creating tickets. And these different tickets act as individual environments where you can make updates, and you can make updates and changes, and when the ticket is committed, the rest of the tickets can be rebased to reflect the most current ticket. This allows you to separate the work and get it done. So perhaps for the truck, you have somebody working on the chassis, while you have somebody working on the fuel systems and perhaps document generation, pricing. You could break up the work and make sure that you can get all of these things done to help you go live. Now, quality assurance tools. So this is of course important, and diving deeper into the back end here, you have the ability to open up a front end environment within that ticket test environment. So this allows you to test the products in addition to the different roles that you've created. So you can see how the user interface looks, you can test your constraints, you can see the calculations execute. If there's any conflicts or errors, there'll also be inspections. So you can even get ahead of it with the inspections in the back end, which will also depict this severity. Perhaps it's a simple notification that a constraint's turned off, or maybe it's a fatal error, like a module was deleted and it's referenced in the configuration and it'll cause it to crash. And so you're able to delete those changes as well and revert to earlier stages in the ticket, in the activity log. Another thing to mention here is you can also use Tacton CPQ to output all of your product configurations and the compatibility options in a product variance report. So just a side thing to mention there as well. After the construction of the product structure, and now it's constructing the user interface, so visually constructing that, you can do that with Tacton CPQ's View Designer. This allows you to display your questions in various methods. This could be radio buttons, select menus, drop downs, image grids, text fields. This is where you define your user interface. You can also group your questions in columns, in different categories, defined on the left-hand side. And in the configuration UI, you can also create these different columns. So the page layout is configurable, and the whole goal here is allow you to give your user a guided selling approach, making it simple for non-technical salespeople to configure these complex solutions. So the whole goal here is to hide complexity and really empower your salespeople. Now it's important to mention, we can configure anything. That's what we do. So there's everything from very simple configuration such as cable and wire to very complex configuration like production lines with systems of configurations and interconnected dependencies with nodes. So everything from the simple to the complex we can configure.